Hi, my name is Daniela, and today I'm gonna show you in this video how to train a recurrent neural network for text classification in a federated way, so using the PySyft framework and making use of two Raspberry Pis. So the first thing we got to do is just log into our Raspberry Pis via SSH. Here I already logged in. Uh, Once I'm logged in, all we need to do is simply start up the server worker on every single Raspberry Pi, as the Raspberry Pis are responsible for carrying out the actual computation, so the model training. We're gonna have two models here, which are gonna be trained on every single Raspberry Pi in parallel and in a distributed manner. Now, let's just navigate to the folder where the code for the worker server is. Should be this is the PySyft repository, which I'm gonna link in the video description. Alright, this is the right location. Now, just start up the Raspberry Pi number 1, and we're gonna use this command: run WebSocket server.py minus ID. Let's call it Alice minus port and this is my host name, my IP basically of my Raspberry. Alright, now I successfully detached from the computation via the screen program, so that I don't need to have it here running all the time. It's just in background in the Raspberry. Now let's just do the same thing on the second Raspberry. Okay, run WebSocket server. Let's call it Bob port. Let's give it a different port from the other one, even if we're actually on different hosts. Alright, it's running here as well. Forgot, I gave the wrong. No, it's not IP. And I think I also need to run this screen socket over here. Yeah. Alright. So alright. Socket is ready. Now the two workers are running on the Raspberry Pis. All we got to do now is go to the start up our Jupyter notebook, attach the workers to the computation, and just simply run it there, basically, in the Jupyter notebook. Now we got to run the, this is the wrong folder actually, sorry. Yeah, alright. Yeah, recurrent neural network example, examples, advanced, tutorials, advanced, should be good. Now start up a Jupyter notebook for the federated recurrent neural network example, the one I created, and you can actually find an article about this in the video description. So this is some explanation of what we're gonna do. So based on a certain name, a surname given as input, we're gonna be able to predict to which language of origin it belongs to. For example, Chin will be predicted very likely to be Korean, or my name to be French. Okay, kind of makes sense. Okay, it's still a Latin language, but I'm actually Italian. Okay. Now, what we're gonna do is, first of all, you're gonna have to get your dependencies sorted, and you can do that on your computer as well as the Raspberry Pis. But for now, we're just gonna go through this Jupyter notebook. So let's just restart the current kernel, I guess, and let's run every single line. So first of all, we're gonna have to import some basic libraries for our program to work. Now we're gonna have some data preprocessing and transformation, and for that purpose, we're gonna basically carry out many different steps to have data in the right format. You can find all the details in this Jupyter notebook and in the article in the video description. So we're going to import some functions. Now load up the data from the disk. It seems that we got many different data sets with Greek surnames, Italian surnames, Chinese surnames, and so on. Let's initialize our language dataset, which we're gonna feed into the federated training loader function, and the arguments for our program. For example, you may notice over here we're gonna perform 10,000 epochs, and we're not really making use of the federated averaging because of the poor performance that it was having, because of the batch size, which is set to very small over here. And this amount of epochs means that probably we're gonna have to wait for quite a while for the training to finish. So let's reduce it to like 5,000, I guess, just for the purpose of this video. Now let's just keep it to 10,000. I'm probably gonna speed up the video for you to actually enjoy a better training procedure and a more accurate model. Actually, two models. Yeah, this is just a description of the format in which we're gonna want the data to be in. So we're gonna want two lists. So we're gonna unwrap the two dictionaries into a list for the X, so the data points, and the categories of the data points which we wanna predict. And this is basically what it's doing here. So taking the names, taking the labels, and converting them converting each one of these into a list. Now, because PyTorch cannot understand text, we're gonna have to turn every single category into a number. For example, as I'm saying here, the Greek category is gonna become a 0. And there's quite a few examples of the categories corresponding to the different names. These are German names, and free is the category corresponding to German. Now, we are gonna have to do something similar for the words and the characters in the words themselves. So we're gonna turn every single character into a vector of characters. So based on the overall length of the alphabet which we're considering, we're gonna set a 1 in the very position where the character is. So in the case of an A, we're gonna put a 1 at the very beginning, and all the other characters are gonna be set to 0. A word is simply a vector of character embeddings. So this is a character embedding, and a bunch of characters put together just make up a word. If you think about C++, yeah. So we're gonna have to turn every single character into a vector, and then every single word into a vector of character vectors. And that's what we're doing over here. This is an example with the word Adamidis, and we can see this is every single character making up the word. As you can see, because the first letter is capital, it's not in the first position. Unlike the A, which is lower capital, lowercase, is actually set to 1 at the very first position. And this is done for every single character. Actually, you see D is at the 0, 1, 2, 3, at the 4th position if we start counting from 0. Now, what we're gonna do is some further data transformation, because we're gonna have to turn our list of words into a NumPy array. We're gonna have to identify the longest word in the data set, and then fill vectors of characters up to the size of the longest word. For example, after finding that the longest word in our dataset is 19 characters long, we're gonna have to put over here many vectors, like many 0 vectors up to the size 19, in order for every single word to have the same shape and be actually fed into a NumPy array. And that's what we're doing just here. As you can see, the longest word is 19 characters long, and we have transformed our Adamidis word into a vector with many different 0 vectors in it. to make up for the missing characters. And finally, as I mentioned briefly, we're gonna turn this NumPy array, this list into a NumPy array, and introducing one extra dimension, which we're gonna remove with this function. All right. Now, I noticed quite a few issues during the training procedure after the data was processed this way, and namely, because we have all of our data like in a list, in a NumPy array, if we take a random sample from it, like from 1 to n, if we take a random sample from this, we may take samples from the dataset which is most represented from the, let's say, the mini dataset which is most represented in the overall dataset. Because we have 18 different languages of origin and the Russian one makes up for more than 50% of all the categories, it's gonna be very likely to take a data sample and a corresponding category from the Russian category. So what we do is we reorganize our data such that we can firstly pick a data sample and a category from one single language of origin. So we randomize over the categories, and then we take a random data sample from that category. So basically we randomize over the 18 different categories and not over all the different data samples. For that purpose, we're gonna need the starting indexes of every single category in the list of data samples. And that's what I'm doing right here with this function. So just finding the starting index of every single category in the list of data samples. And this is just defining a couple of functions for taking a random category index, randcat index, which doesn't stand for cat, it's just a category index, and then based on that category, taking a data point from that very category. All right, that was the hardest part, I will say. As you know, like 60–70% of the time is actually spent on the data preparation and transformation in machine learning data mining projects usually. Now we're gonna have to define the recurrent neural network model, which we're gonna use as part of this small example. So this is our recurrent neural network with a couple of hidden layers, final softmax function for text classification into one of the 18 different languages of origin, the different categories. And now comes the interesting part. So I'm gonna have to define the workers over here. So I'm gonna comment out the virtual workers and define the actual workers. Now, we just need to define a couple of more functions for the training. These are the more complicated functions for training, but basically, okay, the federated averaging is not actually being used because of the poor performance that I noticed. But what we're doing here is just we're having to a dictionary of models, which we're sending to the two different workers, Alice and Bob. And in every single iteration, we're gonna get the corresponding model of the data point which we've picked in the current epoch. So yeah, we do some more data transformation in order for the data to be in the right format, and we basically zero-grad the model at initialize the hidden layers at every single iteration, every single epoch, zero-grad the model. So and then perform the forward passes over the different hidden layers of the model, and then backpropagate. This was actually having quite a few issues with the previous version of PySyft, but I recently submitted a pull request to fix this problem, and now it should successfully perform backpropagation, and we update the model's weights based on the gradient that we got. Yeah, we send back and forth the model in order to update it. You see here, firstly we get it on the server, and then we send it back to the worker. And yeah, all we do is just we get a random batch, random data sample, and corresponding category. And finally, we can yeah, uh, understand if our prediction was correct or not, and then react consequently. So at the end, we're gonna have a nice plot too. But for now, firstly, we got to put the different data samples into a list onto which we're gonna randomize during the federated training process. Now, this may take quite some time, usually. Yeah. So we're gonna have to wait a bit. Probably I'm gonna speed up the video right here. Alright, it's finally done. The training of our recurrent neural network is done. I actually simulated the training locally because the training on the Raspberry Pis was taking too long, like more than 2 hours remotely, whereas in a LAN, so in the same local area network, this was taking about 30 minutes. But for the purpose of this video, I just decided to show you the training locally. Yeah, otherwise I would have needed to yeah, just wait too long in front of my computer here. Alright, so training is done. Now let's plot the loss over the different epochs. And finally, we can use the trained neural networks, which, since we trained two different neural networks, one on Alice and one on Bob, to predict the language of origin of different words. So, for example, I'm trying to predict, for example, the language of origin of a Chinese name, and it's indeed predicting Chinese, that's correct. And here it's predicting something similar, so it's Korean. Whereas with the second one, we're trying to predict my name, Daniela, and apparently it turned out to be Russian. Ah, it's close enough. The second most likely turns out to be Italian, but Russian seems to be the most likely one for the worker Alice. And for the other one, seems to be French, apparently. But yeah, that's cool. We can try and, I don't know, put in a different name and see what it will predict with the different neural networks. Yeah, apparently it turns out Nicola is a Russian name, or Czech. Yeah, that's cool. So I guess for today, that's it. Um, Let me know if you managed to run the present script and if you managed to run this especially on Raspberry Pis. Thank you for watching. See ya.